Hey everyone, in today's video we're going to be evaluating the 6 trigonometric functions of an angle based on point x, y, and with a radius. So first we're going to draw an angle in standard position. And so this is an angle in standard position, and this is going to be a point x, y. And this is the origin 0, 0. And this right here is going to be the radius. And the radius is the distance from this point 0, 0 to this point xy. So the radius can be found by using the formula r equals the square root of x squared plus y squared from the point xy. And r is always positive. So the reason why we have this formula is because if you look here, this, like the vertical leg, and this is like the horizontal leg. And as you can see, it makes a right triangle. And so the point xy makes a right triangle with the origin 0, 0. And the Pythagorean theorem is C equals the square root of one leg plus the other leg. And as you can see, these two formulas are the same. And so that's where we get this formula from. So now we're going to evaluate the 6 trigonometric functions based on the point xy and that radius. So sine y over the radius, so this opposite side over the radius. Cosine is this adjacent side over the hypotenuse, which is the radius, so x over r. Tangent is this opposite side, which is the y, over the adjacent side, which is x. Cosecant is just the reciprocal of sine. Secant is just the reciprocal of cosine. And cotangent is just the reciprocal of tangent. So you might be wondering why these work, because these are evaluating this angle right here and not your angle in standard position. So these work because you're evaluating the trig functions of the reference angle. And this is the reference angle. And the trig functions for any angle in any quadrant are the same as the trig functions of the reference angle of that angle, but it might just be a different sign depending on the quadrant that you're in for the angle in standard position. So as long as you just include the right signs of x and y, then you'll get the correct answer. So what I mean is for example, cosine of 2 pi over 3 is negative half. And the reference angle for 2 pi over 3 is pi over 3. So cosine of pi over 3 is equal to half. And 2 pi over 3 is in quadrant 2, and so the x values are negative, and so you just make it negative half for 2 pi over 3. So it's the same, it's just the sign is different. But as long as you just put the right sign for x and y, because it should already be the right sign, when you plug it in, then you'll get the correct answer. So now we're going to do an example. So we're given point 3, 4 on the terminal side of angle theta, in standard. So we're going to write out the radius formula. So r equals the square root of x squared plus y squared. So we're just going to plug the values in. So r equals the square root of x, which is -3 squared, plus y, which is 4 squared. So r equals the square root of 25. And r is going to be positive because the radius is always positive. So r equals 5. So now we have x equals -3, y equals 4, and r equals 5. So we're going to evaluate the trig functions. So sine is y, which is 4, over r, which is 5. Cosine, which is x, which is -3 over the radius, which is 5. Tangent, which is y, which is 4 over x, which is 3, and it's going to be negative because x is negative. Cosecant, which is just the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So now for our second example, we're going to be given sine of theta equals -3 over 5, and we're in quadrant 4. So we're given that sine equals -3 over 5, and sine equals y over r. So we know that y equals -3 and r equals 5 because the radius is always positive. So if there's a negative, then it has to be either x or y, and in this case, y. So we know what y is and we know what r is, but we don't know what x is. So we're going to use the radius formula to find what x is. So we're going to do r, which is 5, equals the square root of x squared plus y squared, which is -3 squared. So to solve this, we're going to square both sides. So 25 equals x squared plus 9. We're going to subtract 9 from both sides, and we get x squared equal to 16. And so we're going to take the square root of both sides to get x equal to +4 because we're in quadrant 4, and in quadrant 4 x is positive. So now we're going to evaluate the 6 trig functions. So sine is y over r, which we're already given. Cosine is x, which is 4, which we just found, over r, which is 5. Tangent is y, which is -3, over x, which is 4. Cosecant is just the reciprocal of sine. Secant is just the reciprocal of cosine. And cotangent is just the reciprocal of tangent. So now for our last example, we're given cosine equal to -5 over 13, and we're in the third quadrant. So we know cosine is equal to x over r. So we know that x equals -5 and r equals 13 because x has to be negative because r is always positive. So we don't know why, so we're going to plug x and r into the formula. So r, which is 13, equals the square root of -5 squared plus y squared. And so we're going to square both sides. 13 squared is 169 equals 25 plus y squared. We're going to subtract 25 from both sides to get y squared equal to 144. We're going to take the square root of both sides to get y to equal -12 because we're in the third quadrant, and in the third quadrant both x and y are negative. So now we're going to evaluate the sixth trig function. So sine equals y, which is, we found that y is -12 over r, which is 13. Cosine is, we're already given that, so it's 5 over 13. Tangent is y, which is -12, over x, which is -5, which equals 12 over 5. Cosecant is just the reciprocal of sine, so it's -13 over 12. Secant is the reciprocal of cosine, so -13 over 5. And finally, cotangent is just the reciprocal of tangent, which is just 5 over 12. So that is it for today's video. I hope you guys enjoyed, and I'll see you in the next one.